Yeah, good day, guys. So, welcome to Monmas Prefado University tuitions. So, my name is Dr. Monmas. So, Dr. Monmas from Monmas Prefado University. Our number for business is this. So, you can enroll with us. We provide online lessons and also physical lessons. Our office or our center now, we are based in the University of Botswana. So today's topic is geometrical optics, mechanics, vibrations, and waves. Is our today's topic. Geometrical mechanics, geometrical optics, mechanics, vibration, and waves. This is our today topic. So let us move on to mechanics. So what is mechanics? Mechanics is the study of this branch of physics which deals with what we call forces and their ability to cause movements. So motion. So in mechanics, so we have what called measurements. So measurements are used to describe natural phenomena. So what is happening? So you use measurements to describe that. What are the natural phenomena which you are talking about? Like the amount of something which filled on something like volume. So meters cube measurement. The natural phenomena which you are talking about are the things such as what distance traveled. Like someone moved from point A to point B, but because of measurement you can be able to say someone moved 15 kilometers or someone moved 10 kilometers. So measurements needs to define the standards. So define standards, in other words, we are saying that the measurement need to be unique and general, so that you don't overestimate or underestimate. So measurements, you can say that that the equilibrium estimates, so estimates which are in the standard. So characteristics of standards for measurements. For you to say this thing is a measurement, what is it that the thing should have? For you to say a meter is a standard measurement, what qualifies it, or what are the characteristics or attributes for such? So we can say that standard measurements are those measurements which are readily available. Example, time. If you measurements of time, a stopwatch, and all these seconds, there should be something which are readily available, so that we can use it all. So that when we say Usain Bolt was the fastest man from 2010 to 2015 or 2010 to 2019, we all use the same measurements. So they must possess some property that can be measured reliably. Measurement is not, they are not supposed to what? They are not supposed to change. They should yield same results. Example, a meter ruler, if it's an instrument of measure, if you use it in Britain, use it in Canada, use it in Botswana, South Africa, they should also have the same reading. They are not supposed to change. For you to say that this thing is a second measure, should make sure that it measures seconds everywhere, and anyhow, like the results should need to be the same. So these are about measurements. So measurements cannot change with time, like the same way we see measurement be used in the 19th century. They need to give same results even in the 21st century, and also in the 20th century, and even in the 22nd century. They need to give the same measurements, so that scientific theories and experiments can have a meaning and a sense. So example, if you use a meter ruler, you say that it has 100 centimeters inside. It need to be 100, even in the other 100 years to come, millions of years to come. So it should not change over time. If you see something change over time, that does not qualify to be a standard a measure, to be a standard measure. So we move on to fundamental quantities in mechanics. So in mechanics, there are three physical quantities which are like fundamental or basic quantities. So these three basic quantities, we have length, we have mass, we have time. So in other words, we are saying in mechanics you can only measure length, you can only measure mass, and you can only measure time. So in other words, what we are saying is that these are the only things that you can measure. Example, let us take an example of speed. So speed is equals to what? Is equals to distance over time. Distance is a length, you see, and time is time. So in other words, when I'm measuring speed, know that you are just measuring the length and you are dividing the length by what? By the time. You are dividing the length by the time. So these are the three basic fundamental quantities of mechanics. I hope we are together. I hope we are together. We are together. So we need to know these fundamental quantities in mechanics. So other fundamental quantities not used in mechanics are temperature, electric current, luminous intensity, and amount of substances. These are not used in mechanics. So all other quantities in mechanics can be expressed in terms of the three fundamental quantities. The three fundamental quantities. Example: acceleration, energy, and force. They all can be expressed in these three fundamental quantities. In these three fundamental quantities, let us express at least one in these fundamental quantities. So we have acceleration. So when you measure acceleration, you know that acceleration is change in what? In change in velocity over time taken. So in other words, because we said that when you are measuring for acceleration, you are not really measuring for this for the name acceleration. What you are measuring is either you measure length, is either you measure time, is either you measure mass. So what is velocity then? Velocity, you need to know that velocity is distance over time. So that's this is equal to velocity. I agree. I hope you understand. So over the time which was already there. So when we do our mathematics, d over t is the same as d over t squared, meaning that acceleration is distance over time squared. So let us try to let me wrap this so that I can continue with my work in another new slide. Okay, so let me continue my work. So we say that acceleration is equals to what? Is equals to d over t squared, which is distance is the same as length is the L over t squared. You can see that acceleration, you can express it as acceleration is equals to what? Is equals to length over time squared. So in other words, for you to measure acceleration, because is a physical quantity of mechanics. In other words, we are just measuring the length or the distance divided by the time squared. It means that if the length is 5 meters and that thing took 2 seconds, it's going to be 2 squared, meaning that is going to be 5 over 4, and your answer there is going to be your acceleration. Your answer there is going to be your acceleration. Your answer there is going to be your acceleration. So now moving on to system of units. We are saying that standard units for fundamental quantities dictate the system of units for all mechanical quantities. So units should be clearly and accurately defined. So one system of units used universally is the scientific community. In the scientific community is the SI system of units. So scientists have to come together and agree in this SI system of units. So standard fundamental units are meter, kilogram, and second. So these are the standard units. So for definitions and for history, you may go to chapter 1 of page 4 and 5 of that book of physics. I forgot the name, so you can just go and reference to that book of physics. So now in physics, you are going to learn about prefixes. So prefixes should correspond to the powers of 10. They need to correspond to the power of 10, and each prefix has a specific name. Each prefix has a specific abbreviation, and also the most common prefixes that you are going to use in physics are: the name of the prefix is tera, and the abbreviation is T, and the power is 10 to the power 12, and we have giga, G, 10 to the power 9, we have mega, M is the abbreviation, 10 to the power 6, kilo, K, 10 to the power 3, centi, C, 10 to the power 2. So you need to know this, that sometimes I can just write a value and say 10 micro. So 10 micro, let me say 10F. 10F, in other words, I'm saying that that is a number which is 10 times 10 to the power negative 15. So that is going to be 10 femto. But in physics, you need to be sure that that to know again the powers of those prefixes in order to calculate. Because when I say 20 M, capital M, times 15 C, small c, in other words, I'm saying that 20 mega times 15 cent. So what will be your answer? And you need to make sure that, also you need to know that in physics, when the answer is too long or it has many decimals, you need to express it in terms of powers. So we have derived and pseudo units. What are derived units? So sometimes in physics, you are going to use derived quantities or units. So derived quantities can be expressed in terms of fundamental quantities. Example, volume is one of the derived unit. So it can be expressed in terms of what? In terms of length. The same way I expressed the acceleration, and the same way I expressed speed. So pseudo units are also used in place of SI units. So pseudo units, example, these are just the units which are used sometimes to honor a scientist. Example, Newton. So Newton is a pseudo unit. But in physics, you guys are going to convert. And in convection, when I give you a pseudo unit, you need to make sure that you convert that unit into a standard unit, so that you can be able to use it in conversion. So conversion of units. So sometimes need to convert units. Could be from one prefix to another within the same system, or from one system to another. So examples of conversion of units. So consider the British systems of units are being converted to the SI unit, the standard international system of units. So 1 inch is 2.54 centimeter. 1 foot is you said that 1 feet is 2.54 centimeter. 1 inch is equals to 2.54 centimeter. 1 foot is equals to how many centimeter? 30.48 centimeter. 1 yard is equals to what? It's equals to 91.44 centimeter. 1 mile is equals to 528 foot. Then the question states that we need to now convert. We need to now convert 75 miles per hour to feet per second. Again, B, you have to convert it to meters per second. So let us convert that. So in conversion, as I stated above, that you'll be converting from one system to another, or one prefix to another, or one prefix to another. So the question that you have done before, I think you have been asked to do, it was convert 75 miles per hour to, I'm going to take it to what? I'm going to take it to meters per second. So the first one you are going to do it for yourself. So when you convert, you look at this the values which were given by what? By the question. So it's going to be 75 miles. So over, this value is going to be a negative, as it was expressed as -1 to the power -1, meaning that hour is at the bottom. So when you convert, you multiply by what? By 1. So you are going to convert from one dimension to another. How many dimensions are you seeing there? There's miles represent the length dimension. The hour represent the time dimension. So miles, you are going to take miles to meters. Then you are going to take hour to seconds, because you are going to convert the length to length. Then you are going to convert the time to time. So when you convert, you are going to use the principle of what? Dividing by 1. So let us divide the one below. So divide by 1. So you are going to convert the meter to what? Miles to meter. Because miles is up here. You see that miles is up. You are going to put it at the what? Bottom. Because why? At the end you want to cancel miles to what? To miles. Then you put meter up. Do we know the direct conversion of miles to meter? Do you know the right conversion from miles to meter? We don't know. So if you don't know, what are you going to do? Let me erase here. If you don't know, what are you going to do? You are going to say, okay, but for the conversion of miles to meter, this is the process. We are going to convert from miles to what? To meter. We don't know the direct conversion of miles to meter. But what do you know? We know the direct conversion from what? From miles to what? To foot. Again. Then from foot to what? To centimeter. Then from centimeters to what? To meter. Agree? Previously, I gave you a conversion formulas, like 1 inch is this centimeter, this centimeter is this foot. Again, so what we know is that we know the conversion of what? From miles to foot. Then we know the conversion from foot to what? From foot to centimeter. That one we know. So what are you going to do now? We are going to erase this part so that I present my work afresh again. So this is what we know. So we have 75 miles per hour. We multiply by 1. We know that 1 mile is the same as what? 1 mile is the same as 5280 foot. This is 1. So when I say you multiply by 1, this thing is 1, in other words. Because when I say someone walked 1 mile and I say someone walked 5,280 foot, is the same. Like now, 100 centimeters divided by 1 meter is the same as 1. That's why I say you multiply by 1. So I'm going to erase this, erase. So now we have this times this. Then we cancel mile to mile. Mind you, we are dealing with 1 dimension at a time. So we are going to multiply 75 by 5280 foot over what? Over hour. Then we want to multiply. Now we are converting foot to what? We are converting foot to to centimeter, because we know the conversion of foot to centimeter. Because foot is up, we put it down and say 1 foot is how many centimeter? Is equals to 30.48 centimeter. Then we cancel foot, so you are left with 75 times 5280 times 30.48 centimeter over an hour. Then we know that you convert now centimeter to what? To meter. We know that 100 centimeter is equals to what? It's equal to 1 meter. Therefore we cancel a centimeter, then we cancel a centimeter. So we are left with 75 times 5280 times 30.48 meter, because this part at the top, I'm going to multiply this part at the top, then I multiply the part at the bottom, which is going to be 1 hour times 100 centimeter. Let me erase this. So you are left with what? You are left with 75 times 5280 times 30.48 meters over 1 hour times 100, because so there's not 100 centimeter, it's just 100. Like the centimeter cancels centimeter. So we are now done with the conversion of what? Of length. Now we go over to the conversion of what? We are going over to the conversion of hour. We know that because hour is at the top, because the question said convert to meters per second. So we're taking 75 miles per hour to what? To meters per second. So because hour is at the top, is at the bottom there, when you convert, you are going to multiply it at the top. Then 1 hour to seconds. Hour to seconds, we know that is 3,600 seconds. This is the one. When I say someone took an hour to move, and I say someone took 3,600 seconds, this is the same. So I think I cancel hour there, and I'm left with 75 times 5280 times 30.48 meters over 100 times 3,600 seconds. Because from the question you are given the format in which your units are to be expressed. So you are going to write meters per second squared. No need to get it wrong, because you know that they need to be expressed this way. Therefore you work up, you take your calculator, then you multiply whatever is at the top and at the bottom, then you divide, then you see what? Then you see your answer. So that I will say my answer is X centimeters. Then we move on to dimensions and dimensional analysis. So a cuboid, what are the dimensions of a cuboid? So the dimension of a cuboid is length, height, and width. So in other words, whether length, height, or width, all these things are what? Are distances. So in other words, all these are what? These are length. So the fundamental quantity which is behind all these things is a length. So let's just learn about the dimensions of physics. Dimensions which are there in physics, like we derive them most of the time from what? From fundamental quantities. But dimensions are being denoted by what? By brackets. L just being there is a physical quantity, but when you put brackets on top on that L, those square brackets, that means now you are communicating to us that this thing is a dimension. So dimensions of L. So let me just do like this. This means dimensions of L are L. This is not this. You get me? This is not that. So this is not this. But M in brackets is equals to M. These are dimensions of M. So the idea behind the dimensions is that, let's assume that we say that, okay, volume is length times width times height. The length, the width, and the length, these are all distances. This is length cubed because the length times width times height. Okay, so the length is going to be length, width is going to be length, well, the height is going to be length. So this is the same as L cubed. So let's take another homo, and we say another quantity. Let's take the quantity that we're going to take is, let me change which quantity. Others are long, so my phone I can just be writing. Don't understand. So I'm repeating speed. Speed is equal to the distance over time. At the end, speed is length and time. I put brackets, I put brackets, I put brackets, I put brackets. So this means dimensions of speed. So dimension of speed is going to be what? L over T, which have been expressed as L T minus 1. You get me? I hope you are able to home. So now we move on to the dimensions of mass, which are m, dimensions of time, which are t. So what to be dimensions of volume? So the dimensions of volume are going to be, volume is length times width times height times what? Times height. Brackets, 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 which are going to be L cubed, because it's going to be length times length times length. You put this brackets, 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 so your answer is L cubed. I hope I have answered that question for you. Dimensional speed, we have made it. So the other 20 physical quantities of physics, both strain, momentum, force, energy, area, all those, you can go and make the dimensions and you submit through my personal email. So suppose have two cubes that have the same volume. What will be their dimensions? Compare. The dimensions have to be the same. So dimensional analysis can be used to check if the formula is correct. Can be used to check if the formula is correct. Can be used to determine dimensions of one side of the function using the side with a known dimensions. Example, dimension analysis can be used to check the correctness of what? They can be used to check the correctness of the equation. Example of the correctness of the equation that we can just talk about. Let me just do like this and say that show that the expression v k1u plus k2at, where v is the final velocity, u is the initial velocity, a is the acceleration, t is the time, and the k1 k2 are dimensional constants, is dimensionally correct. What are you going to show? What are you going to do? You are going to I we have v. Look here, we have v. We have been told that v is velocity. So we have this question is going to have three parts, which is v is equals to k1 u plus k2 at. So you are going to put an equal sign here between this, like you substitute this plus with an equal sign, meaning that this question have three parts. We have the part of v, you have the part of k1 ku, you have the part of k2 at. So we are going to compare and say, if this equation is dimensionally correct, it means that the dimensions of v, if the dimensions of v is speed, we know that dimension of v is speed. So dimension of speed, we know that is what? Is the LT negative 1. For us to say that this equation is dimensionally correct, this section A have to give us LT negative 1. Section B, section B also have to give us LT negative 1. Section C also have to give us LT negative 1 for us to say that this equation are dimensionally correct. If they're not giving us that, it means the equation is not dimensionally correct. Not dimensionally correct. So for dimensional constants, the dimension is 1. If like the constants are numbers, if we hear that something is a constant, it means the dimensions of that thing is 1. Like dimensions of 5 is going to be 1, dimensions of 100 is going to be 1. Any number that dimensions is going to be 1. So I don't know why in this notes they did it like that, but okay, so it's still okay. I'm going to explain this format. So we are going to take V, which is said is section A, section B is section B, part B, and part C. We're going to take part A, we compare it to part B. Then we take part A, you compare it to part what? To part C. After all, we have to take part C and compare it to part B. If A is the same as B, A is the same as C is the same as B, that means that the equation is dimensionally correct. So then we compared. So V is speed. You need to know how to derive dimensions. I hope I taught you how to derive dimensions of speed, and also I also taught you how to write acceleration in standard units. Okay, so that is the dimension. How to derive dimensions. So we move on, and we say V is what? The first V, dimensions of V and K give us what? The left hand side give us LT negative 1, because how does it give us LT negative 1? Remember, V is speed. Speed is length over time. I put brackets, so the answer is LT negative 1. So what is that part giving us? The right hand side also give us 1 this, because we said that K is dimensionless. K is what? Dimensionless. So it gives us 1. So it means that the left hand side and right hand side are the same. So left hand side and right hand side are what? Are the same. That means that for that part, when you compare A and B, they are the same. So we go to another part, which is that part there. The left hand side give us LT negative 1, the right hand side give us LT2T. What does it mean? The left hand side and the right hand side are the same. So most of you, I know you don't understand the maths here. So when you multiply this guys, if we have LT over T minus 2, I mean T2, at in some manner, so T2, it's going to be what? It's going to be in terms of mathematics, going to be LT. No, I just took this and wrote it in negative things, positive things. So it's going to be 10 times T minus 2, again, which is what? Is 1 here. In other words, when you work, because in mathematics we say we work out the powers. So when we work out the powers, it's going to be T negative 1. So you can see that, because if we say that this is section A, section B, section A, section C. If A and B are the same and A and C are the same, it means that C and B are the same. I guess this one are the same. I hope it's just logic there. So you can see that this equation A is the same as B is the same as C. Okay, that means that this equation is dimensionally correct. The equation is dimensionally correct. So since the dimensions of left hand side are the same as the dimensions of the two parts of the right hand side, the expression is dimensionally correct. So go and try other questions about the correctness of dimensional analysis, but sometimes they can be, it's not like they're all going to be dimensionally correct. Hell, that's what thing. Yeah, it's dimensionally incorrect.